Okay, welcome to the deep dive.
Great to be here.
So today we're tackling a learning puzzle, something I know I've definitely hit before.
Oh, yeah. What's that?
You're going through examples, maybe learning a new skill, and you feel like, yeah, okay, I'm following this. And
Mm.
then bam, you try it yourself, and it's just blank screen, brain freeze.
Right. That dreaded moment, the I thought I had it moment.
Exactly. So we're diving into how we can get, well, a much clearer sense of what we actually understand when we're picking up new stuff, new cognitive skills.
Especially in that phase right after seeing worked examples, right? When you're meant to start solving problems yourself.
Precisely. We want to help folks dodge that whole, I think I get it, but do I really feeling?
Yeah, it's all about sharpening our self-assessment skills. We've all felt that gap, between thinking we understand and actually being able to do it.
Totally. And it turns out this isn't just like a universal frustration. It's actually something researchers study.
It is. We're drawing from a study today, actually. It's from the Educational Psychology Review.
Right. It's called How to Optimize Self-Assessment Accuracy in Cognitive Skill Acquisition When Learning from Worked Examples. Sounds a bit academic, but the core idea is super practical.
Definitely. It's based on actual experiments, not just theory.
So our mission today basically is to pull out the actionable stuff from this research, insights that can help you, the learner, get a more accurate read on your own understanding.
So you know when you're actually good to move on, or maybe when you need to double back and look at those examples again.
And the whole context here is this worked example approach. Can you quickly recap that?
Sure. It's pretty common in learning, especially for problem-solving skills. You first study a detailed step-by-step solution that's the worked example.
You see how it's done.
Exactly. And then you try to solve similar problems yourself.
And our focus and the study's focus is really on that tricky transition, isn't it? From just seeing it to actually doing it.
That's the spot. Because that's where the self-assessment really comes into play. How do you know if you're ready?
Okay, so the study zooms in on two main ways we tend to judge our understanding right after trying those first few problems on our own.
Mm-hmm.
First one is performance-based cues. Basically, how well did you actually do on the problems?
Did you get the answers right? Or
Yeah,
were you, making mistakes? Pretty straightforward.
yeah. And the second way is what they call explanation-based cues.
Right. This is more about how well you think you can explain how to solve the problems.
Like, could you teach it to someone else? Do you feel like you grasp the why behind the steps, not just the what?
Exactly. Your perceived ability to articulate the process.
Which sets up the big question for this deep dive, really. Which one gives you a better picture?
Performance or explanation, which is more reliable for judging your understanding, especially early on.
Yeah, and are there maybe ways to make our self-assessment even sharper, kind of regardless of which cue we naturally lean towards?
These are the key questions the researchers tackled. They ran experiments to get some answers.
And those findings are what we want to unpack. So let's get into it. What did they find, first off? That comparison performance versus explanation as a gauge.
Okay, so in their first experiment, the results were pretty clear, actually.
Yeah.
When learners based their self-assessment on how they performed, just getting it right or wrong, their judgment of their own understanding was generally more accurate
More accurate than when they based it on.
than when they based it on how well they thought they could explain the solutions.
Huh. That's really interesting because, like, the common wisdom is often if you can explain it, you truly understand it.
Right. It seems intuitive.
So, why might just focusing on getting the answer right be a better indicator, at least in those early stages?
Well, the researchers suggest a couple of things.
Hmm.
First, when you're just starting out, you might solve problems correctly using what they called shallow strategies,
Shallow strategies,
like just mimicking the steps from the example without really understanding why those steps work or what the underlying principle is. Think of like learning a math formula and just plugging numbers in without getting the concept.
okay, yeah, I can totally see that. I might follow the recipe from the work example and get the right answer for those specific problems, but I don't really grasp the cooking technique, so to speak.
Exactly. So initial success doesn't always mean deep understanding.
Right.
And on the flip side, when you're asked how well you can explain it, you might overestimate.
Why is that?
Well, you've just seen a detailed explanation in the worked example, right? So it feels fresh in your mind. It might feel like you could explain it yourself, even if you haven't truly like internalized the logic or the connections between the steps.
Ah, the illusion of explanatory depth.
Kind of, yeah. So the key thing here for learners is Don't get fooled by that warm, fuzzy feeling of understanding right after you've read through an example.
Mm.
Your ability to actually solve a new problem based on it is often a much more realistic check.
Okay, that makes a lot of sense. So, bottom line from experiment one, part one, focus on the success rate. Am I getting these practice problems right? And that's a more solid initial measure than just my feeling about explaining it.
That's the gist of that first part. But they also looked at something else really cool in that first experiment.
Oh, yeah.
They looked at timing. Like, when do you tell learners what cue to focus on performance or explanation? Does it matter if they know before they start solving the problems or only after they're done?
Ooh, okay. That sounds like it could make a difference. If I know I'm supposed to be thinking about how I'd explain this while I'm actually doing the problem,
Yeah.
I might tackle it differently,
Right.
right? Compared to just solving it and then thinking back, can I explain that?
Exactly. You might pay
Yeah.
attention to different things during the process itself.
I can relate to this. Like when I was learning some coding, following examples was one thing, but trying to articulate the logic later, that often showed me where the gaps were.
And that's exactly what they found in the study. It didn't matter which cue they were told to focus on performance or explanation.
Okay.
The learners who were told before they started the practice problems, which cue to monitor, their self-assessments afterwards were more accurate.
Wow. So just knowing the assessment criteria in advance helps you tune in better during the actual learning.
That seems to be the idea. It's like knowing the essay question before you read the chapter. You pay attention differently.
Right. You're primed to notice the relevant bits.
Yeah, the researchers think that actively, attending to that specific cue during problem solving helps you build a more accurate mental record compared to trying to reconstruct it all from memory afterwards.
Okay, that is a super practical tip. Before jumping into practice, consciously decide, am I judging myself on getting it right or on being able to explain it? And then keep that in mind while working.
Exactly. Just setting that intention beforehand seems to sharpen the later self-judgment.
Did they check if that extra mental load caused any problems? Like, did it make people worse at solving the problems because they were also thinking about explaining?
That's a good question. They actually measured mental effort and performance.
Hmm.
And interestingly, they didn't find any significant difference. Telling people the cue beforehand didn't seem to, hurt their performance or make it feel overwhelmingly harder.
Okay, good to know. So just being aware of the assessment cue doesn't necessarily derail the learning itself.
Seems not, based on this study.
All right, so recapping experiment one. Performance is often a better initial cue than explanation feeling. And knowing your cue beforehand boosts accuracy for either type.
You got it.
But they didn't stop there, right? You mentioned a second experiment. They dug more into the explanation part.
They did, yeah. They wanted to figure out why explanation-based cues might be less reliable initially, and if they could sort of improve them.
Makes it more accurate.
Exactly. Their thinking was, well, maybe learners struggle with explanation cues because they don't really have a clear benchmark. Like, what does a good explanation even look like in this context?
Ah, they lack clear criteria.
Potentially. And also, maybe people don't naturally tend to actively explain things themselves while they're solving problems. It's an extra step.
Right, you're focused on just getting the answer.
So in experiment 2, they tested these ideas. They gave some learners specific criteria like, here's what makes for a good explanation, or here's what good performance looks like.
Okay, giving them a rubric, basically.
Kind of, yeah. And they also prompted other learners to actively self-explain as they went. Like, okay, why did I do that step?
So trying to make that explanation process more explicit and structured.
Precisely. They manipulated both things, giving criteria for interpreting the cues and prompting self-explanation during the task.
Okay, and what happened? Did giving this extra support make the explanation cue as good as the performance cue for self-assessment?
No, this is where it gets a bit more nuanced. It turned out that yes, explanation cues could become roughly as accurate as performance cues, BUT.
But only if.
Only if the learners got both kinds of support. They needed the clear criteria for what a good explanation involved, and they needed the prompt to actively self-explain while they were solving.
Wow, okay, so you needed the full package, basically. Just thinking about explaining wasn't enough. You had to actively do it and know what doing it well meant.
That's exactly what the results suggested. If you took away either the criteria or the self-explanation prompt, the people relying on explanation cues were still less accurate in their self-assessments compared to the ones just using performance cues.
That's really illuminating. It feels like using explanation as a self-check is powerful, but it requires more conscious effort and structure, especially when you're new to something.
Exactly. The researchers use the term cognitive scaffolding. Those extra instructions, the prompts, they act like temporary supports to help learners use that explanation strategy effectively.
Whereas just checking, did I get it right, is maybe more straightforward, requires less scaffolding initially.
That seems to be the implication. Performance cues are often more direct, and maybe learners are just more used to monitoring their own success rate on problems. Using explanation effectively as a self-assessment tool, while valuable, seems to need a bit more deliberate setup.
Okay, this is all super helpful. Let's try and distill this down now. For the listeners, for the learner out there, what are the main actionable takeaways from all this?
Okay, I think there are a few key things. First, especially when you're in that phase right after worked examples, trying problems for the first time, really pay attention to your performance.
Feeling it right or wrong?
Yeah. Did you solve them correctly?
Yeah.
That seems to be often a more reliable mirror of your current understanding than just how you feel about your ability to explain it.
Right. Don't just breeze through practice assuming you get it because the example looked easy. Actually check your answers.
Check your answers. Exactly. Second big point. Be aware beforehand of what you're going to use to judge yourself.
Decide before practicing. Am I focusing on success rate or my ability to explain?
Yes. Making that conscious choice before you start seems to significantly boost how accurate your self-judgment is later on. It primes your brain.
Sets your internal focus. Makes sense.
And the third point, related to explanation. If you do want to use explanation as your gauge.
Which can be a good thing for deeper learning.
Absolutely.
Yeah.
But just vaguely thinking, yeah, I could probably explain this, might not cut it for accurate self-assessment.
You need more.
It seems you benefit from having clear criteria in mind. Like, what does a good explanation actually involve? Maybe articulating the why for each step, not just listing the steps.
And actually doing the explaining.
And ideally, yes, actively engaging in explaining as you solve, maybe talking it through, writing notes, something to make it explicit. But the caveat is, this takes more effort.
Right. The study suggests it might not be the most efficient route for that very initial self-check compared to just looking at performance.
Correct. Performance is often simpler and more direct initially. Explanation, while a powerful learning tool, needs that extra support to be an equally reliable assessment tool right at the start.
That's a really crucial distinction, actually. Explaining helps you learn deeply, but your feeling about explaining isn't always the best immediate measure of understanding.
Well put. Your actual success on the problems themselves often gives a more grounded reality check in those early moments.
So don't mistake the potential power of explanation as a learning strategy with the reliability of feeling explanatory as an immediate self-assessment cue.
Precisely. Lean on performance first, perhaps.
This is genuinely eye-opening. It pushes back against some common assumptions about learning, doesn't it?
It does. We often have these biases, like overestimating how well we grasp things. This research gives us some concrete ways to be a bit more, well, objective with ourselves. Become more effective, more self-aware learners.
Okay, so we've heard that focusing on performance, especially early on, and being aware of your assessment criteria beforehand can really sharpen your self-assessment accuracy. So here's a final thought for you, the learner, to mull over. How might you consciously structure your next learning session? Maybe one that involves worked examples. Could you deliberately track your performance on practice problems?
Like actually tallying right versus wrong.
Yeah, being deliberate about it. And then maybe afterwards, consciously try to explain the solutions, perhaps with some clear criteria in mind, like explaining the why, and see how well that aligns with your actual performance.
Comparing the two kinds of evidence for yourself.
Exactly. It's really about taking more control, isn't it? Moving from just hoping you understand to actively checking and knowing, one accurate self-assessment at a time.
It's that shift from the fuzzy feeling of, I think I get it, towards a more solid, evidence-backed, okay, I know where I stand with this. Really valuable stuff. Thanks for joining us for this deep dive.